G'day everyone, Peter Sheffer here. Here today to talk to you about performance metrics in software development teams. Performance metrics are really important because they help our stakeholders and our management know that teams are working at their best, or if there's challenges in the process, that they're being identified and being rectified. So let's discuss about what are some potential options for performance metrics that you can use in agile software teams. I want to start by saying that performance metrics can change the behavior of software teams, and therefore it's really important how we select those metrics and what we actually use. We need metrics that will shine a light on where there are deficiencies in our processes or ways of working so that they can be remediated. We want metrics to be valuable and we want them to be actionable. But most importantly, we want metrics that still allow the iterative process of agile development so that teams don't feel constrained or pushed into meeting a deadline or some other artificial constraint. So it needs to enable the iterative nature of the work that they do. So what should we use? Let's have a quick look for a moment at what is known as cycle time and lead time. There are different schools of thought on how these should be measured. I like to use Finn Goulding's definition, which we see here, and that's Finn Goulding down the bottom left-hand corner. With this, the lead time is measured from the time that a task is created within a team through to the time that it's made available in production and ready to be used by a customer. Cycle time is a measure from when work is begun, normally by an engineer and they've started doing development, through to when the work is in production, same as ending in lead time. These two metrics alone are very powerful in telling you where there are deficiencies in the process of software development. By making them the focus of improvement, which means being able to decrease them, teams will identify areas that they can remove wasteful activities. The end result is that the customer or the end user will get served faster and be happier as a result. I'm going to give you a metaphor for cycle time and lead time that'll make it easier to comprehend. If you're anything like me, then you like to go down to your local coffee shop and pay $5 for a takeaway coffee. When I go to my favorite coffee shop, they take my order, and usually it goes on a piece of paper, and it sits in a queue waiting for the barista to finish what they're currently doing. Lead time starts from the moment that my order has been taken, but the cycle time hasn't started yet. Cycle time doesn't start until the barista looks at my order, takes a clean cup, and begins making the coffee. The barista finishes the order by carefully placing a lid on my cup and calling out my name. At that point, both the cycle time and the lead time ends. So the lead time is longer than the cycle time, and it tells us how long the customer has to wait for their request to be fulfilled. Cycle time tells us how long did it actually take to build the item for it to be made. Throughput is a pretty simple one. I think we mostly all know it. It's simply a measure of how many items were completed in a specific time frame. And so a cafe might measure the number of completed coffees in 1 hour or in 1 day. They might ask, how can they increase the throughput during busy periods like the morning rush to keep up with the demand and during those periods and avoid losing customers? And the team can come up with ways of increasing throughput, which might include things like having a second coffee machine and a second barista. Flow efficiency is a ratio that tells us what percentage of time was a work item actively being worked on compared to the time it was spent waiting to be worked on. This ratio can tell us that there is low efficiency in our processes where items are waiting in a queue or blocked for some reason. We measure the time spent in a wait state and time spent in an active state, and we compare the two and turn that into a percentage. Here we can see that an item has spent 33% of its time in being worked on, so value being added, and 67% being waited on, which means it's sitting there idle. We can apply this also to our portfolio pipeline and use that information to identify where work gets stuck in invisible queues in the organization and aim to lean out portfolio processes. Lead time distribution measures the frequency with which work items are completed in a time frame. In Agile, we often measure the time required to complete work items in days. Looking at the graph, we might see work items being completed anywhere between 1 day and 30 days. We can see that more items are being completed on the lower end of the scale in a short number of days, and only a few on the upper end. If there is a large distribution, then the work is very lumpy and it doesn't have a lot of consistency. Some items are really big and some are really small. This could tell us that some of the work is either complex or it's very challenging for the team, or it could tell us that the work items are too big for the team to be able to complete in a short time frame. And if 30 days is how long it takes to complete an item, it's most likely not getting completed in a sprint. And that means the sprint goal is not being achieved. And it also means that work is not ready to be reviewed at the end of the sprint. So targeting a shorter time frame where all work is completed in the sprint is a really good focus. We say that a team is more predictable when their distribution is bunched close together, and ideally it is at the lower end of the scale down here, meaning that the majority of work items are easily completed and they're consistently small. So we like to see a very narrow distribution with a peak at the lower end of the scale. Similar to and related to lead time distribution is a measure of predictability. Predictability is a good measure for telling us if teams are in a flow state. When teams are in a flow state, their predictability increases greatly and their throughput dramatically increases as a result. This measure is closely related to the lead time distribution I just walked you through, but I will discuss how it works and what the definition is in a separate webinar because it requires some explanation to make sense. Changing how you define predictable away from meeting project deadlines and constraints is one of the simplest shifts that you can make towards greater agility and working in a more agile and iterative manner. It means that management and stakeholders are not looking to say you're predictable by meeting a deadline. This measure of predictability is more about how consistently teams are able to deliver pieces of work into production. The final measure we will have a look at today is called the rate of innovation. Rate of innovation is a term given to us by Elon Musk, and he says it is the only metric that matters, and it is what sets companies apart. Capabilities are a company's competitive advantage and not their assets, is what he says. So let's have a look at the rate of innovation for Tesla. We actually know this because a person called Joe Justice, who worked at Tesla for a time, provided us with this information. Tesla introduces 60 or more new parts into production and sale every day of the year, 365 days per year. This includes the manufacturing processes, certifications, the embedded software, the support and maintenance procedures, the logistics, the supply chain management, and more. Tesla deletes 61 or more parts every day. The total part count continues to be simplified and complexity is reduced. Tesla is now 8 times more profitable per car than Toyota, despite the fact that Toyota invented their lean just-in-time production system last century and have been applying it for decades. In closing, there's a lot of different metrics that you can use and you have to choose the right one that represents the right information for your stakeholders and your managers. It's important to shift away from project constraints and using those as a definition of performance, because Agile is not a project methodology. It's a way of delivering value rapidly to your customers and innovating rapidly. So in closing, if you're planning on moving to use these metrics and you think they will help your organization, then I invite you to work with me towards making the change, because there is change management aspect of helping your stakeholders to understand these metrics. And it's really important the way that you measure these things. It's also important helping your teams to understand why we measure these things this way and what the importance and significance of these metrics are. Thank you very much. I'm Peter Sheffer. Goodbye.